Hello guys, welcome back to the course. In this video, we are going to build a forecasting model to forecast infectious disease rate using time series. Okay, as usual, we are going to display the first 5 rows of the dataset. So I'm going to type in data.head and I'm going to hit compile. Okay, so the next thing that we're going to do is to check how many diseases in these datasets, all right? So I'm going to create a variable called count diseases, and we're going to assign value to this variable. So it's going to be data, and inside this bracket it's going to be disease, which is this column name. So I'm just gonna copy and paste this column name, and we're going to put it inside this bracket and unique. All right, and down here we're going to print it, right? So print number of diseases, and we're going to copy and paste this variable and then put it inside here. And we are also going to do the value count. So just type in print data disease dot value counts. Okay, so now I'm going to run the code, and as you guys can see, this is the output that we got. So in total there are 65 diseases in this data sets, right? So we have MBSs, relapsing fever, what else, hepatitis, measles. Okay, so we have 65 diseases, guys. So when you're building your forecasting model, just pick one disease that you want to forecast. Okay guys, so in this video we're just going to pick like one random disease, and we're going to forecast the rate for that disease in 2015. So if you remember, these datasets record the data from 2001 to 2014. So we're just going to do the forecast for 2015 using these historical data. So we're going to pick like one random disease. So I'm going to pick chlamydia. So if you remember in the previous video when we did mapping infectious disease per county, as you guys can see, like almost all counties have the same disease, and the name of that disease is chlamydia. So we are going to forecast the spread of chlamydia. Okay, so now let's get started. Let's add another block of code, and the first thing that we're going to do here is to convert year to datetime format. All right, so let's get started, guys. Data, and inside this bracket we're going to have this column's name. So I'm just going to copy and paste that and put it inside this bracket. All right, and we're going to convert this column year to datetime format using pandas. So we have pd dot datetime, pd dot to datetime, and inside this parentheses we're going to have data, and inside this bracket we are going to have year, and we're going to change the format. So the format is going to be equals to year, right? Okay, so I'm just going to compile this line of code. Before continuing the project, let me remind you that we are going to use STL, or time series decomposition model. Okay, so make sure that you imported this library first from statsmodel.tsa.seasonal import STL, right? Okay, so now let's continue, guys. I'm going to add another block of code, and we are going to filter the data for chlamydia and use only year and rate columns, right? So I'm going to copy and paste the name of the disease, chlamydia. Okay, so I'm going to copy and paste that, and just to be consistent, the variable is supposed to be lowercase, so chlamydia data. All right, so we're going to filter the data. So data, inside this bracket we are going to have disease. All right, so I'm going to copy and paste this column's name, and I'm going to put it inside this bracket. All right, and we're going to have equals to chlamydia, right? So I'm going to copy and paste the name of the disease that we want to forecast. So if you want to forecast like different diseases, for example, you want to forecast amoebiasis or or maybe missless. It's totally up to you, all right? So just replace Chalumdia with whatever this is that you want to forecast. It's totally up to you. Okay, so this is how you filter the data sets. And we are also going to have year and rate. Okay, so we are done. I'm going to hit compile. And I'm going to set the year column as the index, all right? So I'm going to copy and paste this variable that we already created up there. So Chalumdia data.setIndex. And inside this parenthesis, we're going to have year, comma, in place equals true. And let's hit compile. Okay, it works. Let's add another block of code. And this time we're going to extract the rate column as a one-dimensional array. So I'm going to create a new variable called Chalumdia rate, like this. So it's going to be equals to Chalumdia data. And inside this bracket, we are going to have rate, which is like this column, right? Dot values. And let's hit compile. Okay, it works. Let's add another block of code. And now we're going to perform seasonal decompositions of time series, STL. Okay, so I'm going to create a new variable called STL result. Okay, so just type in STL like this. So this is the forecasting model that we're going to utilize. So again, just a quick reminder, make sure that you already imported this library. All right, so STL, inside this parenthesis, you're going to have Chalumdia rate. So just copy and paste this. That's going to be the parameter inside this parenthesis. All right. And we are also going to have the second parameter, which is seasonal. And we're going to set this to 13th. And we are also going to have period. And we're going to set this to be equals to 2, right? And we're going to end this with dot fit, open and close parenthesis. Okay, so let's hit compile. And let's add another block of code. This time we're going to do the calculations. So we are going to calculate the forecasted rate for Chalumdia in 2015. And you might be wondering like, hey Chris, why don't we just forecast Chalumdia rate for 2023 or 2024? Well, let me tell you, this data set only recorded infection cases from 2001 to 2014. So the data sets that we're using right now is not very up to date. So if you want to forecast the infections rate for 2023 or 2024, you will need to use more up-to-date data, right? Okay, so let's go back. So I'm just going to copy and paste this variable, right? So STL result dot seasonal, and because we set the seasonal to be equals to 13th, so we're going to use that inside this bracket. So negative 13th like this, dot mean, because we want to calculate the average first, right? Okay, so the next thing that we're going to do is to create a variable called forecasted trend. So it's going to be STL result again. So I'm just going to copy and paste that because I'm too lazy to like retype it, to be honest with you. So STL result, the trend, and still the same. So I'm just going to copy and paste these inside the bracket, right? And the same thing, we're going to calculate the mean. Okay, so you might be wondering like, what does this line of code do? Okay, so like the first one, it calculates the mean of the last seasonal component. Meanwhile, the second line of code, it calculates the mean of the last trend component, right? And now we're going to do the same for the residual. So forecasted residual. It's going to be STL result dot residual. And the rest is the same, right? So you have dot mean. Okay, so the next thing that we're going to do here is to do the calculations for 2015, all right? So I'm going to create a new variable called forecasted rate 2015. So it's going to be forecasted seasonal plus forecasted trend plus forecasted residual. And you might be wondering, like, why do you sum this up? All right, so let me explain. So if you go to Google, guys, and just type in time series decompositions equations, I'm going to show you the equations that we're using. Okay, so as you guys can see, we have additive decompositions. So YT equals T plus S plus R. So in this case, T represents the trend component, S represents the seasonal component, and R represents the residual components. So if you notice, this concept is exactly the same like what we have here, right? So we have seasonal, trend, and residual. Okay, so the next thing that we're going to do is to print it, right? So just type in print forecasted Columbia rate for 2015, right? And we're just going to copy and paste this variable and put it inside here, right? Okay, so now we're going to plot the STL decompositions. We're going to plot the seasonal trend decompositions down here. So we're going to have STL result like this dot plot, and don't forget we are also going to add plt.show. All right, plt.show like this. Well, I think we are done, so I'm going to run the code. Okay, as you guys can see, this is the forecasted rate for 2015, 293.38. So if you want to round it up, it's going to be 293.4. And this is the plot. So the first one represents the trend, the second one represents the seasonal, and the third one represents the residual, right? Okay, guys, so that's how you build a forecasting model using time series. I think that's it. That's all you need to know. I'll see you guys in the next video. Bye.